For about a week now, I've been trapped inside Cole Gilbert's television. It's completely black and white, there's not a lot of room to move around. It sucks. But anyway, one of the things you see when you're inside his television is a lot of Luigi Circuit. And while he was driving around on Luigi Circuit, I started noticing that the sun seemed to move around. See, normally when something is distant on the horizon, it doesn't seem to move relative to you or the surroundings. But I was noticing something different with the sun on Luigi's Circuit, and that got me thinking, how far away is the sun on Luigi's Circuit? And that is the question that I set out to answer today. So how do we measure the distance to the sun? Well, we can't reach the sun, so we're going to have to triangulate its position. So to do that, we're going to need 2 points and some lines, and you'll see what I mean later. So we're going to call this point 1 and this point 2. Now we're going to drive from point 1 directly towards the sun. When we reach a wall, or in this case a slope, we're going to stop because that will throw off our position, and we're going to look at Funky's head on the mini-map and kind of record his position. Now we're going to move to position 2 and do the same thing. When he reaches this wall, we'll stop and record his position. So now we need to measure the distance between points 1 and 2. Now we don't have a measuring stick or anything we can directly measure the distance with, but we can calculate the distance using velocity and time. We know that Funky Kong, when in a mushroom and a wheelie, travels at 120 kilometers per hour. So we can use that speed, calculate the time it takes him going at that speed to get from point 1 to point 2, and using those, we can calculate the distance. So I goldened while in a wheelie from point 1 to point 2. I thought I had a video of this, but I guess it got lost, or maybe I never took it. Either way, I don't have it, so you're just going to have to take my word, but I did it. Now, at point 1, the time on the clock showed 25.255. At point 2, the time was 31.412, and that's a difference of 6.15 seconds. So it took me 6.15 seconds to travel this distance at 120 kilometers per hour. Now, 120 kilometers per hour is 0.03 repeating kilometers per second. When you multiply this by 6.15 seconds, we find that the distance between points 1 and 2 is 0.20523 kilometers. Now, if this were your high school math class, your teacher would probably tell you to use the law of cosines, show all your work on your paper, and box your answer when you're finished. This is the real world, and I don't want to do any of that. So I'm not. So instead, we're going to use a program called SolidWorks. And SolidWorks is great because you can import pictures, as you can see. And so the picture I've imported here is one with all 4 funky heads on the mini-map. This is point 1. This is where we drove to after point 1. This is point 2. This is where we drove to after point 2. And we're going to draw some lines in between these Funky Kong heads. So we're going to use a pixel kind of in the middle. How about that tan one right there? And then we're going to draw it to this guy right here. So that's our first line. And we're going to draw another one in between these. So there's that one right there. And then I think it's this pixel right here. So we've drawn our lines, and we need to fix these lines so they don't move. So we're going to fix them. And then we need to extend the lines because we want to find the point where these lines intersect. Both of these lines are pointing towards the sun, so where they intersect is where the sun actually is. So let's draw our line. It's not going to be parallel at first. We can fix that. So we want to make this line and this line parallel. So you saw it snap to become parallel. And we're going to do the same with this one right here. We'll just draw it down here, make it parallel. There you go. So this is where the sun is. The last thing we can do is make this point coincident with this line. So there we go. And there is where the sun is. So now we can draw any line from the mini-map to this point right here, and we can calculate the distance from that point to the sun. One thing we do need to do is measure the distance between these 2 points. So, if you recall, we calculated that the distance between these 2 points is 0.20523 repeating kilometers. Now, we need to measure this line right here. The length of this line is 6.34056 inches. So 6.340565 inches equals 0.20523 repeating kilometers. And so when we divide both of these numbers by 6.340565, we get that 1 inch equals 0.0323683 kilometers. So now all that's left to do is draw any line from the mini-map to the sun. So I want to do one from like the closest point and the farthest point. Let's go right here. And the length of this line is 15.83 inches, which is 0.512 kilometers. So this point on the mini-map is just over half a kilometer away from the sun on Luigi Circuit. We can draw another one from the farthest point, so like back here somewhere. And that line is 25.01 inches. And that is 0.8095 kilometers. So as it turns out, the sun is actually pretty dang close to Luigi Circuit, which means it's probably getting a little toasty down there. No wonder Funky Kong wears those stupid looking sunglasses.